In this example, in the study of a city, the population density in people/hectares and the distance from the city center in kilometers was investigated by picking a number of sample areas within the following results. So we have a table that shows areas in terms of from A, starting from A until J, and we have distances starting from 0.6, and then it varies across until so for A 0.6, for B is 3.8, for C is 2.4, D is 3, E is 2, F is 1.5, G is 1.8, H is 3.4, and I is 4, and J is 0.9 in terms of distance in kilometers. The population density in terms of people per hectare, and for A is 50, B is 22, C is 14, D is 20, E is 33, F is 47, G is 25, H is 8, and I is 16, and J is 38. Now, based on the information that we have, we're asked to draw a scatter diagram to represent this data. So we will take the data that we have and we will plot it on a graph, and this is how the data will be represented as shown here. And so this will be our response and answer for part A. For part B, we're asked to describe the correlation between distance and population density. So in this scenario, there is a weak negative correlation, and in terms of understanding why it is a weak negative correlation, on the right hand side it shows you how would a weak correlation would look like in terms of the data and how when they are populated, and also the relationship between the variables that we have. So for negative correlation, we have one variable increasing and the second one decreasing, so it's almost an inverse relationship. For part C, we need to interpret the answer for part B. So in this scenario, as distance from the center increases, the population density increases, and this is almost aligns for what we said in part B in terms of being a negative correlation and the data being weak. And this will be our answer for this question. In this example, Heideko was interested to see if there was a relationship between what people earn and the age at which they left education or training. She asked 14 friends to fill in an anonymous questionnaire and recorded her results in a scatter diagram as shown below. In the first part, we asked to describe the type of correlation shown. Heideko says that her data supports the conclusion that more education causes people to earn a lower hourly rate of pay. So there is almost a relationship between the two variables. So in terms of our explanation for part A, it's a weak negative correlation. So in this scenario, as shown, the data it is scattered, and the negative correlation comes that as one variable increases, the second decreases, and this is our explanation for part A. For part B, we need to give a reason why Heideko's conclusion might not be valid. So respondents who left education later would have significantly less work experience than those who left education earlier. This could be the cause of the reduced income shown in the results of Heideko. And this will be our explanation in terms of why we have the negative correlation and also why the conclusion might not be valid. And this will be our answer for this question. In this example, some research was done into the effectiveness of a weight reducing drug. 7 people recorded their weight loss, and this was compared with the length of time for which they had been treated. A scatter diagram was drawn to represent this data as shown on the right hand side, in the center of the center here. And so in part A, we are asked to describe the type of correlation shown by the scatter diagram. So in this part, our response will be a positive correlation, and it is a positive correlation because as one variable increases, the second also increases, so it's a direct relationship. For part B, we need to interpret the correlation in context here. So the longer the treatment, our response will be the longer the treatment, the greater the loss of weight. And this will be kind of correlates with what we anticipate in terms of being, in terms of our response for part A, which is a positive correlation. And this is our answer for this question. In this example, the average temperature and rainfall were collected for a number of cities around the world. The scatter diagram shows this information. For part A, we need to describe the correlation between average temperature and average rainfall. So in terms of our response, there is no correlation. So this is an information that we extract from the diagram that we see, as the data is highly scattered and we do not see either one increasing by the impact of the other or vice versa. For part B, we need to comment on the claim that hotter cities have less rainfall. So the scatter graph does not support the statement the hotter cities have less rainfall, and this will be our response for this question. In this example, 8 students were asked to estimate the mass of a bag of sweets in grams. First, they were asked to estimate the mass without touching the bag, and then they were told to pick the bag up and estimate the mass again. The results are shown in the table below. So we have students from A to H. Estimate of mass not touching the bag in grams were also around. For A is 25, B is 18, C is 32, D is 27, E is 21, F is 35, G is 28, and H is 30. An estimate of mass holding the bag for A is 16, B is 11, C is 20, D is 17, E is 15, F is 26, G is 22, and H is 20. So based on the information that we have, we can create our, for part A, we are asked to draw our scatter diagram. So this how the information based the scatter diagram would look like based on the information that we have. So we plot the weight touching versus weight not touching. And for part B, we need to describe and interpret the correlation between the two variables. So in this scenario, that we can see it is a positive correlation, because as one variable increases, the second also increases. So each student's tendency to guess lower or higher than the mean was the same in both tests, and this will be our response for this question. In this example, Donald was interested to see whether there are a relationship between the value of a house and the speed of its internet connection, as measured by the time taken to download a 100 megabyte file. The table shown shows his results. So time taken is 5.2, and the house value will be around 300. When the time is 5.5, the house value is 310 in terms of thousands of pounds, and 5.8 equates to 270. So time 5.8 equates to house of 270. Time taken 6 equates to 200, 6.8 equates to 230, 8.3 in time equates to 207 in value, 9.3 in time equates to 2.8 in value, 13 equates to 235 in value, 13.6 equates to 175 in value, and 16 in time taken equates to 180 in terms of thousands in value. So in this case, we are asked to draw a scatter diagram as part of A. So we can plot the diagram as shown here, and for part which is the house value against the time, and for part B, we're asked to explain what type of correlation it is, and we can see from the data that it's a weak negative correlation, as one value increases, that the second one decreases. And for part C, we're asked to give a reason why Donald's conclusion might not be valid. So in this scenario, for example, there may be a third variable that influences both house value and internet connection, such as distance from built-up areas. And this will be our answer for this question. In this example, the table shows the daily total rainfall in millimeters and the daily total hours of sunshine S in lectures for a random sample of 11 days in August 1987 from the large data set. So we have R, which is the rainfall, total rainfall starting from 0, and then the sunshine, hours of sunshine in S, based on the table shown. So the median and quartiles of for the rainfall data are Q1 is 0.1, Q2 is 1.7, Q3 is 4.85. An outlier is defined as a value which lies either 1.5 multiplied by the interquartile range above the upper quartile, or 1.5 multiplied by the interquartile range below the lower quartile. For part A, we need to show that R is equal 21.7 is an outlier. So in this scenario, our explanation will be taking the quartiles. So we have quartile 3 plus 1.5 multiplied by quartile 3 take away quartile 1, which will give us 4.85 plus 1.5 multiplied by, in between brackets, 4.85 take away 0.1, and that will give us the answer of 11.975. Now, as 2.17 is bigger than 11.975, so R is an outlier, and this will be our explanation for part A. Now for part B, we need to give a reason why you might need to include or exclude this day's readings. So the outlier for part A, we need to include that the outlier is part of the distribution of the data. It is unlikely to be an anomaly. For part II, we need to exclude the this day's readings. So the outlier is likely to have no significant effect on the correlation. It would have an effect on any mean average calculated, as one result might not have a significant impact. But in this scenario, it would have an effect on the mean averages calculated. For part C, we need to exclude this day's readings and draw a scatter diagram to represent the data for the remaining 10 days. So in this scenario, we have the data shown for C, and we can see the scatter diagram for on the sunshine, total sunshine in vertical axis, and the rainfall in the x-axis. And for part D, we need to describe the correlation between the rainfall and the hours of sunshine. So in this scenario, we have a weak negative correlation, as shown on the right hand side. That gives an explanation why in the scatter diagram we have this weak negative correlation. For part E, we are asked if there is a causal relationship between the amount of rain and the hours of sunshine on a particular day, and we need to explain the reasoning. So our explanation in this scenario, there could be a causal relationship, as days with more rainfall will have more clouds and therefore less sunshine, and this will be our answer for this question.